Today we're looking at the triangle midsegment theorem. We're going to prove and use theorems about triangles using midsegments. Now a midsegment is a point that is right in the middle of a triangle that connects to the other side of the triangle midpoint. Now every time you have a midsegment that connects two midpoints of two sides of a triangle together, that line is going to be exactly 1/2 the length of the side that's parallel to this, and they're also actually parallel. So XY is going to be parallel to AC, and XY is going to be exactly half the length of AC. So let's look at some examples. We've got a triangle here. We're going to say DE is going to be parallel to, now let's look at DE. DE is here, it's going to be parallel to BC. BDF right here is going to be parallel to this line here, AC. AB is here. That is going to be parallel to FE or EF. You can put it either way. Now DE is this segment right here. It is going to be half the length of BC. But if I cut BC in half, I get two segments. I get BF here and FC here. Both of those are going to be congruent to DE. So DE is congruent to BF and FC. EF is here, it is parallel to this side here, and it's exactly half the length. So if I take each of these segments, they're going to be the same, and these segments are also going to be the same. And both of these pieces are going to be the same length. So EF is going to be exactly the same length as AD and as BD. And once again, you can keep them in, you could say DA or AD, you could say BD or DB. Now AE is this segment here. E is the midpoint, so AE is going to be the same as CE or EC. And then both of those will be the same length as DF. AB is a midsegment in the triangles below. Find the value of X and Y in the length of AB. So AB is here. And so if I take AB and times it by 2, I will get 34. The other way I could think about it is I could take 34 and divide it by 2, and that would give me 17. So I could just say that 3x minus 1 equals 17. I add 1 to both sides of the equal sign. I get 3x equals 18 here. And 3 times 6 is 18, so x has to equal 6. You could also divide both of these by 3. Our next one, now if this is the midsegment, that means that B is right in the center. So 4y has to equal 6 times y minus 1. Now here I'm going to just distribute this 6 through. Let's get y's on one side, numbers on the other. Let's minus 6y from both sides. I divide by -2. A negative divided by a negative is a positive, so y is going to have to equal 3. Now let's look at our x's. I've got this piece right here, and if I multiply that by 2, I'm going to get the 4x minus 2. So I'm going to take 2 times x plus 4, and that's going to equal 4x minus 2. I distribute the 2 through. I want to get x's on one side, numbers on the other, so let's minus 2x from both sides. At the same time, I want to get the numbers on the other side. So I'm going to add 2 as well to both sides of the equal sign. The 2's cancel and the 2x and minus 2x cancel. I get 10 equals 2x. Divide both sides by 2, and I'm going to have x equals 5. 2 times 5 is 10. So those are going to be the two lengths. Now, I forgot to get... find the length. I want to find the value of x and y and the length of AB. AB is going to be this section right here. If x is 4 or x is 5, I put a 5 in here. 5 plus 4 is 9. So this piece would be 9. And then if I plug the 5 in for x, 4 times 5 is 20. Minus 2 is going to give me 18 for this length. And you'll see that the AB length is exactly half of this bottom piece here at the base. Okay, M, N, and O are midpoints of this triangle. So we have 3 mid-segments. We have this piece here, we have this piece here as a mid-segment, and this piece here as a mid-segment. We're going to find the perimeters of MYN and XYZ. So let's go ahead and find MYN. We're missing some pieces, so I think we need to just kind of look at this and kind of fill in some side length. Now, for example, I know that this piece is 4, and so it's parallel to this piece here. So since this ON is 4, this XY piece has to be 8. So this whole thing is 8. But each of these pieces are going to be 4, so if we cut that in half. The same thing is going to happen with this 3 here. So 3 is going to be parallel to YZ, and it's going to be double the length. So if this is 3, this whole length right here is 6, but then each individual piece is also going to be 3. So all together, that would be length of 6. Now, this last one's a little bit more confusing. We've got this 5 here. O is the midpoint, so XO is also going to be 5. Altogether, that is a length of 10. Now, the mid-segment is going to be exactly half of this piece, and it's going to be equal to these two pieces here. So if this whole length is 10, this MN is going to be 5. So now we can go ahead and find the perimeters of MYN. MYN. Perimeter just means we're going to add up all the rim. We're going to go around the rim and add up all those numbers. We have 4 plus 3 plus 5. And that gives us 12 for MYN. Now XYZ is the big triangle here. So we're going to add up all of the sides here. We have this side length is 8, this side length is 6, and this side length is 10. And that gives us 24 for the XYZ. Keep in mind, look at those perimeters. The perimeter of the small triangle is exactly half of the perimeter of the big one. Mid-segments are often used in indirect measurement. So if I know that this is 7, like if I had this is a lake here, and I wanted to find the distance across the lake, what I could do is find the endpoints of the lake and just make a triangle out of it, find the midpoints of these two. This is 7 miles. This distance across the lake has to be twice that. So this would be 14 miles across. Okay, we're going to find, number 5, we're going to find the value of x. Now, if I have parallel lines, I have a transversal here. If you have parallel lines and a transversal, these two are corresponding angles. So corresponding angles have to be identical. So this is 23 degrees, so this also has to be 23 degrees. So we can make the equation x plus 5 has to equal 23 degrees. We minus 5 from both sides of the equal sign, and x is going to equal 18. 18 plus 5 is 23. Okay, number 6, we're going to take these points, plot them, and we're going to connect it to find a triangle. Now, let's just remind ourselves about how to plot a point. We have the x-axis and the y-axis. Whenever we have a point, the x direction goes first, followed by the y direction. So for point A, we have the point 4, 6. That means we're going to go 4 in the positive x direction. This is positive, this is negative. And then we're going to go up 6 in the positive y direction. It goes up and then down is negative. So we're going to just go over 4, 1, 2, 3, 4. We're going to go up 6. And this is where our point is going to be. So this is point A. B is 6, 0. We go 6 in the x direction. Now, if you have a y in the second spot, that's going to mean you don't go up or down at all. So we're just going to do a point there. And C is nice and easy at the origin at 0, 0. We're going to connect those 3 points to form a triangle. We're going to find the midpoint of all 3 sides of ABC. And then we're going to label the midpoint of AB as point D. So let's start with AB. Now, one thing you can do is you can eyeball it if you're able to see, hey, if I go down 3 over 1, down 3 over 1, that's going to be right in the middle. This point right here is point D. The other thing you could do is you can find the midpoint of AB by taking the 2 points 4, 6 and 6, 0 and using the formula x1 plus x2. We find the average of the x's, divide it by how many we have, and then y1 plus y2 divided by 2. So let's add our x's. 4 plus 6 is 10, and then we take 10 and divide it by 2, gives us 5. Add the y's, 6 plus 0 is 6, divide that by 2, you get 3, and this point D would be 1, 2, 3, 4, 5, up 1, 2, 3. So D is the point 5, 3. Okay, so for C, let's see, the next one, the midpoint of BC, we're going to find and call it E. So we can you can eyeball it, or you can add the x's. We're going to go between B and C, so we're looking at these 2 points. Add the x's. 6 plus 0 is 6 divided by 2 is 3. 0 plus 0 divided by 2 is 0. And that gives us the point 3, 0 is going to be our E. Our last one, the midpoint of CA, is point F. Now, I think I might have drawn this just a little wonky, and it looks like a little harder to see where exactly it is. And sometimes you get like things that are halves, and the formula works a little better. So let's just follow the formula since it looks like I drew it a little bit off and I'm not exactly sure where it's at. So we're going to find the midpoint of CA and call it F. So we have 0, 0 and 4, 6. So 4 plus 0 is 4, and then you divide it by 2, you get 2. And then for 6 plus 0 is 6, divided by 2, you get 3. So we're going to go over 2, start at 0, 0, go over 2, up 1, 2, 3. Yeah, and I was quite a bit off when I drew that line, but we'll make it work. Okay, so that is going to be point F. The triangle midsegment theorem states that if a segment joins the midpoints of 2 sides of the triangle, then the segment is parallel to the third side and half as long. So we're going to verify this. Just keep in mind with parallel lines, they have the same slope. So when we find, if both of those lines have the same slope, then they are parallel. So what is the slope of AB? So we're starting at A and going to B. Slope, remember, is going to be rise divided by run. You can also use the formula y2 minus y1 divided by x2 minus x1. So we're going to start with A. I'm going to go down 1, 2, 3, 4, 5, 6, down 6 over 2. This reduces to negative 3. Now let's look at FE. I'm going to go down 1, 2, 3, and over 1. That just equals a negative 3. So both of these have a slope of negative 3, so we're going to say yes. When the slopes of two line segments are the same, the line segments are parallel. So that is showing that these two line segments are parallel. Now we're going to talk about the length. Okay, so we're going to find A. A is 4, 6. B is 6, 0. And then we're going to find the length of FE. F is 2, 3. E is 3, 0. And we're going to use the distance formula. Let's label our points, x1, y1, x2, y2. x1, y1, x2, y2. And we're going to treat those as separate equations, so they're each going to have an x and a y. So we have a square root of 6 minus 4 squared plus 0 minus 6 squared. Square root of 2 squared plus negative 6 squared. You could put that in your calculator. Square root of 4 plus 36 is the square root of 40. And this, if you put it in your calculator, you're going to get 2 square root, I'll use 2 squared of 10. Then let's look at FE. And when I put that into my calculator, this is going to be about 4.47. So not exactly, but approximately 4.47. So when I do the length of FE, FE is the smaller piece, so it should be about half of that. So maybe like 2.23-ish. So let's go ahead and do that square root. X2 is 3 minus x1, which is 2 squared, plus y2 minus y1 is 0 minus 3 squared, square root of 1 squared plus negative 3 squared. 1 squared is 1, negative 3 squared is 9. So this is going to give us the square root of 10, and the square root of 10 is about 2.24. And with the rounding errors, if you double this is going to be exactly the same. So square root of 10 versus 2 square root of 10. So is FE exactly 1/2 of AB? Yes, it is. Okay, so we're going to verify that BC is parallel to DF. So we want to find the slope of BC, and then we want to find the slope of DF. And if those slopes are the same, then the lines are parallel. So let's look at BC, and I just like to look at BC and just count it. Now, if it's straight up and down or straight left and right, you can just count it. 1, 2, 3, 4, 5, 6. This is a length of 6. But since it's a flat surface, it's just 0. The slope is 0. So the slope of BC is 0. DF is this flat surface right here. It is a slope of 0 as well. Now we're going to find the length. The length of BC. BC is here. If we count it, we're going to have 1, 2, 3, 4, 5, 6. This length is 6. And then if we look at FD, the length is 1, 2, 3. Now you can only count it if it's going left and right or up and down. Just keep that in mind. So we have FD is 3, BC is 6, and so DF is going to equal 1/2 of BC. Okay, now for our last one, we're going to do CA and ED. So we're going to find the slope of each of those. So I'm going from C to A. I do my rise divided by my run to find my slope. So my rise, I'm going up 1, 2, 3, 4, 5, 6. And my run is 1, 2, 3, 4. So 6 over 4 is my slope of CA. That reduces to 3 over 2. Now let's look at ED. If I'm looking at this line from E to D, my rise is up 1, 2, 3. My run is over 2, up 3 over 2. The slopes of these two lines are the same, so the lines have to be parallel. Next, we're going to find the distance of CA and the distance of ED. I'm going to go ahead and put the points of each C, A, E, and D into their ordered pairs. We have 0, 0, 4, 6. E is 3, 0. D is 5, 3. Use our formula. x2 minus x1 squared plus y2 minus y1 squared. So for each of these points, we need to just label them as x1, y1, x2, y2. So for CA, our x2 is 4 minus our x1 is 0 squared. Our y2 is 6 minus y1 is 0 squared. This gives me the square root of 4 squared plus 6 squared. You can just put that right into your calculator. This gives us 16 plus 36. This is about 7.2. On the other equation, we're going to do the same thing. We're going to take our x2, which is 5, minus our x1, which is 3 squared, plus our y2, which is 3, minus 0 squared. 5 minus 3 is 2 squared, plus 3 minus 0 is 3 squared. Square root of 4 plus 9, which is the square root of 13. And notice how we have square root of 13 and 2 times the square root of 13. Those are exactly double, or one. Square root of 13 is half of 2 square roots of 13, but this would be about 3.6. And so that is exactly half.